The last thing we're going to be covering today involves what are called island constraints. So we've already seen filler gap dependencies. And ordinarily, as I described earlier, it's the case that a filler can have a gap appear inside its sister. So under ordinary circumstances, anything in this phrase would be eligible to be a location of a gap. But there are certain kinds of phrases that are called islands. And filler gap dependencies cannot link between inside and outside of an island. So a filler outside an island cannot have its gap inside an island. And that's a remarkable syntactic fact. It was discovered over 50 years ago, very early on in the development of generative grammatical theory, and is the subject of a lot of attention in the theory of language. One thing about islands is that they're prominent in learnability debates. So on some theories of islands, they are just sort of brute facts about language structure that would be extraordinarily hard to learn, because they're sort of, first of all, they're second order phenomena. First of all, you would have to learn the filler gap dependency, then you would have to learn a constraint on that filler gap dependency, and that learning of the constraint would involve what's called negative evidence. That is, learning that something is not possible from just never having seen it. And that's always a learnability challenge, because there are all sorts of things that you don't see, and how do you know which of them are things that you just didn't happen to see versus things that can't happen? And islands themselves, even the configurations in which an island could occur, are not necessarily that common themselves. So they're subject of a lot of interest. And so whether a language model that is not trained on explicit syntactic structure could actually have islands fall out as a general property of learning, as a general consequence of learning, would be quite interesting from a learnability perspective. So we're going to try to operationalize that here. And what we're going to do is we're going to take a language model to have learned an island constraint if it fails to propagate the filler-generated expectation for gaps into the phrases that should be islands. So as you saw before, we can measure the expectation for a filler, for a gap that is generated by a filler by the WH effect, which shows up in being surprised when you encounter something where you might expect a gap to occur, and conversely being less surprised when you skip over a gap when it ordinarily couldn't occur. And whatever that sensitivity is should be turned off in the same way that having the gap above the filler should turn it off. So let's see if this happens. So we're only going to give one example of this, but this paper, and this is actually Ethan's work that really is pioneering this. So this is the first paper that he's done on this. And you can look at that paper for many different cases of islands. But the one case of islands that we're going to look at here involves complementizers. So it's going to be back to this case about object extraction from embedded clauses. Like, I know what Alex said your friend devoured at the party. We already saw examples like this. It's perfectly fine. This is what we'll call a null complementizer. Okay, so there's no that or anything in between said and the lower clause. And so this is a green check mark, perfectly fine. I know what Alex said that your friend devoured at the party, also fine. But now notice what happens when I change that to whether. I know what Alex said whether your friend devoured at the party. Now you can probably, because I'm giving the preceding sentences, you can probably understand what that means, but you probably feel that that is weird. And it's weird because whether creates an island. In general, it's hard to have a filler gap dependency that spans from above whether into something that's below whether. And that's one example of islands. So do recurrent neural network models learn this? So here's an example of the pattern that we're going to see. This is one that's familiar before. So this is exactly the things that we saw before. I know that versus what? My brother said our aunt devoured, and then you have either the cake or you have a gap at the party. And this is this familiar effect that we see here. We have the cake is more surprising when you had what, because you expected maybe there would be a gap there. Skipping over the cake is less surprising when you have what than when you have that, because devoured ordinarily require an object, but it doesn't need one when there's a filler in the form of what. So that's the no complementizer condition. Okay, let's see what happens when we change the no complementizer condition to the that complementizer. So we're just going to add the word that after the word said. I know what that my brother said that our aunt devoured the cake at the party, or the other four versions. And this is in the yellow in the graph. And what you can see is that basically you still, the size and direction of the effect is, well, the size of the effect has changed a little bit in both the plus gap and minus gap conditions, but you still have a pretty robust filled gap effect, surprise at not getting a gap, and then a less surprise at getting a gap. And now let's see what happens when we go to the weather complementizer condition. So now basically the weather complementizer has sort of more or less almost completely knocked out the sensitivity of the model to whether what was in the context. There's still a little bit of it here, but it's almost entirely gone. And so certainly you have a massive reduction in the signature processing effects of WH dependencies by having weather intervene. So it seems that actually not only has the model learned the filler gap dependency, but it's learned the island constraint on the filler gap dependency. That is, it does not propagate expectations for a filled gap for a gap into a weather clause. Okay, but now you should still be concerned because maybe this is not about filler gap dependencies. Maybe things that are syntactic islands are things that RNNs have difficulty threading any kind of expectation into. And so we're going to actually do another experiment to test this. And we're going to use what's called a control experiment. And in particular, we're going to use gendered pronouns and expectations for them. So we're going to use gendered pronouns that are set up by culturally or morphologically gendered subjects. So for example, we will see, what is going on here? Yeah, here we go. The actress said that they insulted her friends. So this is a perfectly reasonable reasonable way of continuing a sentence. Her quite plausibly co-refers to actress. And in particular, her should be less surprising here than his. I'm not putting a star next to this sentence with his. The actress said that they insulted his friends, because maybe his refers to some other individual that is not mentioned in this sentence, but it's certainly a little more surprising. So we're going to call this the mismatched sentence. The control, so first of all, we need to double check whether there's actually a surprisal differential at her versus his in these two sentences. If there's no surprisal differential, then we can't even do the experiment because maybe the models haven't learned, for example, actresses are stereotypically female and they create expectations for feminine pronouns more so than for masculine pronouns. So the sanity check is that this effect should be the difference in surprisal. If you subtract the surprisal of the match condition from the surprisal of the mismatch condition, you should have a positive surprisal effect at her versus his. If that works, then we can look at this within islands. The actress said whether they insulted her friends versus the actress said whether they insulted his friends. And if the model is threading the gender pronoun expectation effect into an island condition that is set up with the word whether, then we should still see a gender expectation effect here. On the other hand, if this effect is significantly reduced or disappears, then we should be concerned in terms of our interpretation about the filler gap dependency islands, because it seems that islands just very generally knock out expectations for all sorts of things, not just for filler gap dependencies. And so, once again, this is the syntactic tree, whether sets up an island, but the question is whether this island effect also manifests in expectations for gender. So we'll look into this and see whether that works. So here this is the control condition. We see exactly the effect, the sanity check effect. The model seemed to have learned that actress is a feminine, is stereotypically feminine, and so it expects a female pronoun. And so when you get his, it's in the mismatch condition, you get more surprise than in the match condition. And although we're showing the match is her and the mismatch is his, we have other materials in this experiment that have it reversed, so we're setting up an expectation for masculine pronouns. So it's not about feminine versus masculine overall, it's about matching versus mismatching gender. What about, and so that's the effect. Now let's see whether this manifests also in the case of whether it's inside an island. You get exactly the same effect. So the weather does not change this whatsoever. You see exactly the same pattern. And so islands at least are specific enough that they don't cancel out all expectations for differentiating things. Minimally, for the case of gendered pronouns, we see that islands don't have any influence. So we can actually at least start to address this concern that RNNs have difficulty threading any type of expectation into a syntactic island. Okay, so that's the end for our discussion of learnability and syntactic islands. A couple of things. You can now also go in if you want to look, for example, on SyntaxGym to see how GPT-2 handles these filler gap dependencies. You could set up syntactic islands to test those things out yourself, maybe using one of the interactive tools, and perhaps even use your own GPT-2 implementation with the Hugging Face library that offers it. So thanks, and looking forward to having a discussion with you today.